entropy, and the first we will discuss about the reversible law, and then we will discuss about the entropy. So this chapter which we will start today is the 20th chapter, uh, and it's all about the revision of your basic concepts which you already have studied in your FSC or in metric. Okay. Previously we discussed zero law, then first law of thermodynamics, specific heats, heat capacity, molar specific heats, and then molar specific heats at constant volume and constant pressures. In this chapter, we will discuss the entropy and that of the second law. Okay, the thing is, okay, whenever we think about the entropy, it is obviously a reversible process. There are certain processes that are reversible, and there are certain processes that are irreversible processes. No, reversible processes are those processes that can came back to their original position before without changing any uh, initial parameters. Irreversible processes are those processes in which the process does not reach back to its original position. So the only phenomena that comes to our mind when we discuss about the irreversible process is the time. Time is always moves forward and it never comes back. It is just like that time has the one direction and it moves in the forward direction. It never goes back. We want to, but we cannot move it back. In the same way, there is another process that also takes place in the forward direction, and that is the entropy. Entropy is also a irreversible process, and it always increases, it never decreases. So before discussing the entropy, we will discuss about the reversible and irreversible processes. Okay, it is just like what is the irreversible process? Other phenomena that we can consider, like he said that if a egg is dropped on a floor, pizza is baked, car is driven into the lamppost, large waves road a beach. Now, all these processes are irreversible process. Once you drop a egg, if it hits the ground, obviously it cannot come back to its original process, original form. Why it cannot come back? Again, it has been breakdown. Okay, so it is irreversible process. The irreversible process is basically known as the process. This is the main key point. Okay, irreversible process is the one-way process or the process that cannot be moved back to its original position by means of a small change in their environment. Okay? uh, Without a small change, any small change, you cannot bring it back to its original position. That is known as the irreversible process. Okay? What does mean by the small change? Okay, if you want to move back in the time, obviously you have to build a time machine. Okay? If you want to decrease the entropy, you have to do something that is not possible. Uh, you have to generate a lot of uh, complex situations in order to attain the original position. So these are the irreversible process. So we will discuss about the irreversible process and entropy, and then we will discuss in detail about the entropy. And there will be certain relations that we will discuss in our problems, and we will drive certain relations for the change in entropy and how entropy can be a state property. Okay, up to this point, if anyone has any question. Okay, fine. No, irreversible process, again, as I told you earlier, that irreversible process is the one-way process, and it occurs in the forward direction, not in the backward direction. And if they occur in the backward direction, they are saying that you will get astonished. But in actual case, in reversible process, or if the irreversible process goes back to its original position, overall law of conservation of energy will hold. It will not be violated. Why? It is just like that. If you have a hot cup of a coffee, and if you wrap a hands around the coffee, what will happen? The normal procedure is that the heat will be transferred from the coffee to your hand. Because your hand will be at lower temperature while coffee will be at higher temperature. So obviously, what will happen that energy will flow from the higher reservoir toward the lower reservoir. Means that energy will be transferred or heat will be transferred from the coffee to your hand. But if another thing happens that on the other hand, if heat is transferred from your hand to the coffee, okay, your hand become more cooler while the coffee become more hotter. Overall, this scenario will not violate the law of conservation of energy. Okay, why it will not? Because in a closed system, the amount of heat transferred will obviously in one case it will decrease the temperature, and in the other case it will increase the temperature. Overall, energy will remain conserved. Like if you are dealing with the last scenario which I was telling you, that if heat is transferring from your hand to the coffee, which is not possible because coffee is hot, but we are assuming, let's suppose that it is happening, that heat is transferring from your hand to the coffee. So in this case, some of heat will be transferred from your hand, and the hand will become cooler while the uh, heat, the transferred heat will be used to increase the amount of the temperature of the coffee. So overall, obviously the total heat will remain same, the total energy will remain same. It will remain conserved because your hand will get cooler while your coffee will get hotter. Overall, if we are talking about the closed system with hand and that of the coffee, the law of conservation of energy will hold. So this is what he had discussed here, and then he has given us the example of the helium balloon. That he's saying that let's suppose, okay, if you popped a helium balloon, you would be astonished if all the helium molecules were together in the original shape of the balloon. But again, in a closed system, the overall energy or the law of conservation of energy will not be violated. So another process, ठीक है, that is also irreversible, that is known as the entropy. Okay, so entropy, we always says that okay, it increases. So obviously, if the other way processes we will, if we will talk, it is that the entropy will decrease, but it never happens. Okay, why we call heat death is related to the entropy, heat death of the universe. You already have studied, I think, heat death of the universe. Anyone? Have you studied about the heat death of the universe?
No, sir.
No, sir. No, sir.
एंट्रोपी मैक्सिमम हो सकती है.
अरे सर
Entropy. Basically, there will come a time if we will discuss a universe as a system. Okay, so obviously entropy is decreasing. So when entropy is increasing, so there will come a time that at which the temperature of all the bodies will remain constant. It is just like that you have two cups of water. One is the hot, other one is the cold. If you will place them together, after some time they will come to an equilibrium. Okay, when they will come to an equilibrium, so at that time there will be no transfer of the energy from one cup to the other. So if we are considering universe as a system, as is our system, our all closed system, so entropy is decreasing day by day. So there will come a time, if billion of years later it will come by. So the thing is, the temperature of all the bodies will become same. So at that time, there will be no room for the energy to get transferred from one body to the other body, because all the bodies will be at the equilibrium. So this process is known as basically heat death of the universe. Okay, so it's all because of the entropy, because entropy is always increasing during any thermodynamic process, any process like heat engine. If you are cooling something, if you are heating something, entropy of the
सर आपकी आवाज
system increases. अच्छा, हम entropy की इतनी बात करते हैं, sorry, we discussed about the entropy you already, मतलब if for a simple man, let's suppose if any मतलब simple or the layman ask you what is entropy, so
सर आवाज कट रही।
सर आपकी तरफ से काफी डिस्टॉर्शन हो
is it clear? Are you getting my voice?
नो सर क्लियर नहीं है
नो सर आवाज चली जाती है बीच में
Okay, is it clear?
यस सर
यस सर
Okay, sorry beta, actually I was using mobile data, so there are some problems with the mobile data today. अच्छा जी, जी beta. So no, I was asking you what would be the simple definition of the entropy for a layman. How you can define the entropy? Anyone? यार इतने लाइक बच्चे हो आप लोग, you are all so much intelligent.
सर
And you are, जी बेटा.
रैंडमनेस
सर लैक ऑफ ऑर्डर कह लें
Okay, but we are talking about here thermodynamics. So in what sense lack of actually this is the useless energy. मतलब this is the wasted energy. We can, मतलब if someone asks you, okay, entropy is basically energy, wasted energy, from which we cannot use for any sort of the work. Okay, so this is the wasted energy basically. Whenever there is a thermodynamic process, the wasted energy, I think in your Carnot heat engine you have studied entropy in FSC. When we were in FSC, there was a article in which they discuss Carnot they discuss entropy with respect to Carnot heat engine, and at that point they discussed that this sort of the energy that is wasted, basically wasted energy, that is basically entropy from which we cannot do any useful work. This wasted energy basically score increases, and this increase in the increases the temperature of the universe. Okay, so this is basically known as the entropy. Anyhow, so we were discussing about the reversible and irreversible process. Now we will discuss about the entropy. So changes within a closed system do not set the direction of a reversible process. Rather, the direction is set by the another process which is known as the entropy. मतलब I was telling you, okay जी, heat is you get a heat from the cold body, okay, and cold cup of a coffee, it will be transferred from the cold cup of a coffee to your hand, and it cannot be done by the way that it will get transferred from your hand to the coffee. So the reason is that this cannot be, मतलब आप ये कह सकते हैं कि this cannot be set by the coffee or your hand which were the part of the system. The direction of this transfer, that is from heat should be transferred from your hand to the from your cup of a coffee to your hand, is by another property that is called as the entropy. ठीक है? Now here he's saying that he is discussing about the change in entropy. So the change in entropy is basically uh, it is an irreversible process. सेंट्रल प्रॉपर्टी उन्होंने एंट्रोपी पोस्टुलेट का कहा है, ठीक है. Change in the entropy of a system, that if an irreversible process occurs in a closed system, the entropy of the system always increases, it never decreases. So this is the central postulate of the entropy. It is not a definition, it is just a postulate related to the entropy, that for change in entropy, we can define it as a, if the irreversible process occurs in a closed system, the entropy will always increase, it will never decrease better. So just hold on a second. Acha, no, here he is saying entropy is different from the energy because it does not obey the conservation law. The energy of a closed system is conserved. Why it is conserved? Because it is decreasing from one body and while increasing to the other body. So overall, the energy will remain constant. ठीक है? But in the case of the entropy, it will always increase. It will never decrease. Okay? So it is just like he has given it.
सर कैसे इसके नहीं समझ आए
क्या? एंट्रोपी विल ऑलवेज इंक्रीज बेटा, ठीक है. अब मैं आपको एक्सप्लेन कर रहा था कि इफ यू हैव ए हॉट बॉडी, ठीक है, hot cup of a coffee, and then you have a hand, if you will wrap your hand around the coffee, what will happen? Energy will transfer from the coffee to your hand. Okay. On the other end, if you have a more your hand is more warmer, then obviously heat will be transferred from your hand to the coffee. But in the case of the entropy, if you have another body which is at low temperature, obviously energy will not transfer, ठीक है, to the body. Overall, it does not hold the law of conservation of the energy. Entropy will always increase. ठीक है? So that's why law of conservation of energy does not hold on the entropy, because it will always increase. ठीक है? That's why we call it as a arrow of a time, because with the time it is going forward and forward, it is increasing, it is not decreasing at any moment. ठीक है? He said कि आपके पास क्या है कि एक पॉपकॉर्न है, ठीक है, when you will heat it, obviously क्या होगा, it will explode. So होना क्या चाहिए? Obviously entropy will increase in the backward direction. अगर आप उसको वीडियो टेप किया हुआ है, आपने कोई प्रोसेस वीडियो टेप किया हुआ है, ठीक है, like if egg is you drop a egg on the floor, ठीक है, it will break down, and if you have recorded it, and then when you will replay it, what will happen, that it will come back to its original position. ठीक है? But backward process को क्या होना चाहिए? It should decrease the entropy, but in this case entropy will never decrease, it will always increase. ठीक है? कि backward process में भी जब आप करेंगे कि आप let's suppose पॉपकॉर्न को आपने बनाया है, ठीक है, या आपने क्या किया है कि ओके आपने एक रोटी बनाई है, ठीक है, और आप उसको बैकवर्ड प्रोसेस में रिप्ले करते हैं, उसको आपने कोई ऐसा सेटअप बना लिया है कि यू वर एबल टू पुट इट बैक टू इन इट्स ओरिजिनल पोजीशन, इनिशियल रॉ स्टेट में ले आते हैं, तो एट दैट टाइम टू एंट्रोपी विल इंक्रीज, इट विल नॉट डिक्रीज, ठीक है। सो दिस इज द रीजन कि एंट्रोपी विल ऑलवेज इंक्रीज। यू गॉट द पॉइंट कि नहीं?
सर मेरा क्वेश्चन है, सर कोई इसका हाइपोथेटिकल वे नहीं है, मतलब कैमरा या फुटेज के अलावा कि बैकवर्ड प्रोसेस किया जा सके?
बैकवर्ड प्रोसेस देखें बेटा, इवन फॉर बेटा ये साउंड मेरी आ रही है कट कट के?
नो सर,
नहीं सर, किसी और स्टूडेंट के वो कह रहे हैं कि जी दोबारा बता।
ओके, देखें यहाँ पे प्रोसेस ये चाह रहा है कि लेट्स सपोज कि इफ यू आर एबल टू बॉयल एन एग, ठीक है, चले हम ज्यादा सिंपलर वे में करते हैं। इफ यू आर एबल टू बॉयल एन एग, एंट्रोपी विल इंक्रीज। यही एक नॉर्मल प्रोसेस है ना, ठीक है, इट इज जस्ट लाइक दैट। अच्छा, नो यू आर एबल टू रीबॉयल इट, मतलब रीबॉयल तो नहीं, टू ब्रिंग इट टू इनिशियल रॉ स्टेट, कि ये बेशक कच्चा हो जाएगा, ठीक है, दोबारा कच्चा हो जाएगा। यू आर एबल कि आपने कोई ऐसा प्रोसेस डेवलप कर लिया है कि यू आर एबल टू कह लें कि टू ब्रिंग इट बैक टू इट्स इनिशियल स्टेज, एग को आप रॉ स्टेट में ले आते हैं। इवन दैट देन कि क्या होना चाहिए, लॉ ऑफ कंजर्वेशन एनर्जी क्या कहती है, ओके इन द फॉरवर्ड प्रोसेस एंट्रोपी इज increasing, but in the backward process it should decrease. But if you are bringing it back to its original position, for that purpose too entropy will increase. कि कोई भी आप प्रोसेस लेंगे, even you will bring it back to its original position, ठीक है, या original form, entropy will increase for that process too. It will not decrease. Law of conservation of energy says that कि if your hand is warmer, cooler, heat will transfer to the if your hand is cooler, heat will transfer from the cup to your hand. On the other hand, if the cup gets cooler, ठीक है, heat will transfer from your hand to the cup. But law of conservation of energy says that for one process entropy will increase and for the other process it will decrease. But in actual case, in both cases entropy will increase, it will not decrease. That's why it cannot hold the law of conservation of energy. Now it is clear to you?
यस सर।
यस सर।
ठीक है। अच्छा, अब आते हैं कि आप कोई भी प्रोसेस करना चाह रहे हैं। नाउ यू वर अब्दुल हसीब आस्किंग के ओके वी वुड बी एबल टू ब्रिंग इट बैक टू इट्स ओरिजिनल पोजीशन, लाइक एग हमने किया बॉयल, or then we will be able, we just devise a process in which we were able to bring it back to its original position. So there are basically two steps. One step is from I to F, other step is from F to I. So if you are going from I to F, entropy will increase, and then even then if you are able to bring it back to initial stage I, even then for that process entropy will increase, it will not decrease. So this is the wasted energy that is just increasing temperature of the environment rather than doing some meaningful work. Okay. So अब
एक्सक्यूज मी सर।
जी बेटा।
सर ये तो आप बता रहे हैं कि अगर हम बैकवर्ड में भी करेंगे तो एंट्रोपी इंक्रीज होगी, लेकिन सर इसकी मेन रीजन क्या है, ये नहीं समझ आ रही।
क्या मतलब देखो बेटा, फॉर ईच एंड एवरी प्रोसेस, थर्मोडायनेमिक का कोई भी प्रोसेस है वेयर देयर इज ए हीट इन्वॉल्व, obviously there is the energy that will get wasted, मतलब not all of the energy will be utilized for your process, ठीक है। जब आप लोगों ने कॉर्नर हीट इंजन पढ़ा था, So
efficiency 100% नहीं होती.
नहीं हो सकती, ठीक है. And if let's suppose even if it is 99%, 1% is a wasted energy, that will be a cause of increase in the entropy. ठीक है. Even for the reverse process, if you are going in the backward direction, even then you will not be able to get 100% efficiency. ठीक है. Even then, if you are able to get 99%, which is not possible, I don't think so that we are able to right now create an engine that is 100% or 99% efficient. Even then, what will happen that there will be a waste of the energy, and that wasted energy will be used for the increase in the entropy. अब आपको समझ में आ गई?
Yes, sir. Yes, sir.
चलें, गुड हो गया. सो नॉर्मली इन आवर वर्डिंग, बीइंग ए मुस्लिम, हम लोग यही कहते हैं कि कोई भी बंदा परफेक्ट नहीं है, सिर्फ अल्लाह मियाँ की ज़ात परफेक्ट है. ठीक है. सो दिस इज द रीजन. मतलब देयर इज नो प्रोसेस इन द वर्ल्ड दैट इज 100% जो है आपके पास होगा परफेक्ट. ठीक है. या एफिशिएंट होगा. देयर इज नो प्रोसेस. ठीक है. Even then, if you are talking about the purity of the objects, ठीक है, normally we deal with the chemicals, and later on you will also deal with the chemicals. Even then, we cannot make sure that the thing which we are preparing is 100% pure. We can go up to 4N, 5N, but we cannot go to the 100%. What does mean by the 5N? 99.999%. ठीक है, means 5 9 included. But even then, we cannot claim that it is 100% pure. ठीक है. So for each and every process, if there is some variation for efficiency in thermodynamic process, obviously efficiency does count. ठीक है. So we cannot claim that anything is 100%. Not even 90% we cannot claim. Okay. 90% we cannot claim that there is any engine that can be 190% जो है efficient. ठीक है. What is the efficiency of the petrol engine?
46%.
35 to 40.
It is normally petrol engine was of 25%, 25 to 30%. Diesel engine is of 35 to 40%. ठीक है. This हाँ, मतलब this is the where is the other energy going on? Where is the 60%?
Heat, sound,
wasted. So this wasted energy is basically one of the cause to increase the entropy. Entropy is one of the major beneficiary of this wasted energy. ठीक है. So this is the main process. Okay. So
सर
जी बेटा.
सर अर्थ में ओवरऑल इंट्रोपी किस तरह इंक्रीज हो रही है, मतलब कि कौन कौन से प्रोसेसेस हैं जिसमें ओवरऑल अर्थ के सिस्टम इंट्रोपी इंक्रीज हो रही है?
इंट्रोपी बेटा ओवरऑल जब भी हम लोग बात करते हैं, we usually talk about if you are talking about the heat death. ठीक है. तो हीट डेथ में ओवरऑल हम लोग यूनिवर्स की बात करते हैं. इंट्रोपी में जो है आपका कोई भी आपका प्रोसेस वेयर there is an involvement of the energy, obviously there is the entropy, increase in the entropy. ठीक है.
सर जैसे कि इंडस्ट्रीज वगैरह
जी
केमिकल्स वगैरह बनते हैं
बेटा, you are confusing it to the global warming too. ठीक है. ठीक है. हम लोग कहते हैं जी ओजोन लेयर है, ग्लोबल वार्मिंग इट इज टेकिंग प्लेस. ठीक है. इन एक्चुअल वर्ल्ड के आपका इवन इफ यू आर वॉकिंग बाय, ऑब्वियसली यू आर लूजिंग द एनर्जी. ठीक है. इफ यू आर रनिंग यू आर लूजिंग द एनर्जी. इफ यू आर ड्राइविंग यू आर लूजिंग द एनर्जी. ठीक है. सो obviously in each and every process there is an increase in the, wherever there is the involvement of the energy, there is a increase in the entropy.
ओके सर.
Even if you are building the grills, if you are building the house, if you are building, let's suppose if you are preparing the window grills, ठीक है, how you will prepare them? Obviously you will use a grinder, which is utilizing the electricity. So from where electricity is coming by, again there are engines, that turbines that are producing it, and obviously they are increasing temperature. Even during the cutting and the setting of the dimensions of a grill, obviously you are using the drill, there is a generation of the heat that is also causing an increase in the energy or the entropy. Okay, so overall, in each and every process, wherever you are utilizing the energy, there is a chance that you are increasing the chance. There is a confirmation that you are increasing the entropy of the atmosphere. Okay, of the universe. ठीक हो गया बेटा?
Yes, sir.
Okay बेटा. So कहता है कि there are two ways to define the change in entropy of a system. ठीक है, in terms of a temperature and the energy, the system gains, loses or loses as a heat. ठीक है, and another other way is by counting the ways in which the atoms or molecules that make up the system can be arranged. ठीक है. Now the thing is कि बेटा, we will discuss with respect to the temperature or the energy of a system. Okay, we will discuss entropy in this point of view. Later on, they have asked, but that is not part of your course, okay, how the atomic arrangement can cause the change in the entropy. Okay, so this is also a part of this chapter, but it is not a part of your syllabus, so we will not discuss about this one. Okay. So up to this point, okay, I think it should be clear. Now we will move on to the next, which is the change in entropy. Okay. So change in entropy, we will discuss about it. मेरे ख्याल से we should end the class and then we will move for the.
Yes, sir.
क्योंकि I think it's about 4 minutes left. So rather than starting a new article right now, we should start a new class. Okay, I am just ending the class and then we will discuss about the change in entropy. Okay.